Hello, everyone. Hello, Ignite. Great. Welcome. We're going to be doing an exploration of web development using ASP.NET Core 1.0. My name is Daniel Roth. I'm a senior program manager on the ASP.NET team. And this is going to be an introduction to ASP.NET Core 1.0. If you want to go deeper, we do have another talk later this week. That'll be a deep dive into ASP.NET Core 1.0, so I encourage you to attend that as well. But for this talk, we're going to be talking all about what is ASP.NET Core, what is it for, why did we build it, and what can it do for you. ASP.NET Core is a completely new open source and cross-platform framework for building cloud-based web applications using .NET. And by new, we really do mean new. This is not system.web.dll. It is a completely fresh take on doing web development with .NET. And as such, we actually did a rename a little while ago. We used to call this framework ASP.NET 5. And the reason why we had originally called it that is because while it is new, it should also feel really familiar. Like if you know .NET, you know C#, you know ASP.NET today, like you're doing MVC development, ASP.NET Core should feel super familiar to you. All those skills will carry forward. But it is a complete rewrite of the stack, completely new request pipeline, completely new hosting model. And so a while back, we actually decided that we should really give this thing a new name. And it really is a 1.0 release of a framework. So we renamed it from ASP.NET 5 to ASP.NET Core. You may still see ASP.NET 5 kicking around on the internet. It should really be called ASP.NET Core 1.0. And it is 1.0. I'm super excited that this year, earlier this summer, we shipped the first stable release of ASP.NET Core for all of you to use. It is production ready. It is stable. We have customers that are using it in their production apps on Windows, developing on their Macs, running it on Linux, running it in Docker containers. It's been quite a journey. I think we've been working on ASP.NET Core now for probably over 3 years. At least I think that's how long I've been working on it. There probably were some people working on it a little bit earlier than that even. So it's been quite a journey, and it's great that now we have it. We can give it to you, and you can have it in your hands to actually build your applications. Why did we build ASP.NET Core? Well, there's a bunch of reasons. The first one is that we wanted something that was completely modular. Everything in ASP.NET Core is just a NuGet package. And if you want it in your app, you pull it into your app. If you don't want it, don't add the package, and it's not there. The .NET framework, as it exists today, is great. It's a very mature, it's powerful framework, has a lot of features in it, but it's very monolithic in nature. It's basically all or nothing. You get all of the .NET framework, or you get none of the .NET framework. If you're running a server application, well, WPF is still there, even though you're probably not using any of it, and that has impact in terms of its surface area on your application. With ASP.NET Core, you don't have that issue. You can have, it's literally a pay-for-play model. If you want it, put it in your app. If you don't want it, it's not there. We wanted to have a much faster development cycle for our web framework, and that really means two things to me. The first thing it means is that we can get features to you a lot faster. We just ship on NuGet. We actually shipped our first patch update to ASP.NET Core just a month or two ago, the 1.0.1 patch release. And we expect to continue to do that about every 2 months. We want to get new bits into your hands, if at least that fast. The .NET framework is a Windows component, so it moves at the pace of Windows. Windows is moving faster and faster. Every year they keep getting more and more features to us quicker, which is great, but it still has to move at that pace that Windows can go. We wanted something that we can get features to you faster. Also, the framework was designed with your productivity in mind. You have a much faster inner loop development cycle where you can quickly change your code, see it in the browser much faster by just hitting F5 and refreshing. Those type of user experiences, we wanted to make you more productive. ASP.NET Core was designed with the cloud in mind. This means that we've been able to optimize the runtime. We've been able to optimize the APIs that we build to think about what it means to build cloud-based applications. We have a new configuration model, for example, in ASP.NET Core that is environment-based, so that you can have configuration settings that are relevant when you're in development, and then other settings that are relevant when you're in staging and then in production. And your app can just pick up those settings from its environment. The .NET Framework runs great in the cloud today, but with ASP.NET Core, we really had an opportunity to think upfront, like what does it really mean to build a cloud-based .NET application? We really wanted you to have choice. when building your ASP.NET Core app, choice in terms of what tools you want to use and how do you want to do your development. You should be able to be productive building ASP.NET Core apps with just a command prompt and your favorite text editor. And if that happens to be Vim or Emacs or whatever, that's fine. You can be productive using ASP.NET Core. We, of course, also have a great red carpet tooling experience in Visual Studio with great editors and IntelliSense and debuggers and all that. But if you want to just use a command prompt and text editor or your development tool of choice, that's fine. No VS required. The whole stack is open source and accepting contributions. We've had a lot of great contributions from the community, everything from bug fixes to new features to fantastic performance improvements. The community's been great, and we encourage you, if you'd like to participate in the development of this framework, by all means, join us on GitHub, file issues, give us your feedback, send us your pull requests. Second to lastly, we wanted the stack to be cross-platform. And this is really courtesy of our friends on the .NET team who gave us .NET Core. .NET Core is the new open source and cross-platform flavor of .NET, and it runs on Windows, Mac, and Linux. ASP.NET Core runs happily on top of .NET Core. That allows us to run in all of those environments. Lastly, we wanted something that was fast. With ASP.NET Core, we had an opportunity to really look again at the request pipeline, really optimize, and really get just phenomenal throughput numbers in terms of like requests per second that you can get out of the core pipeline. To get started with ASP.NET Core, the first thing you're going to want to do is you need to go get .NET Core. So you should go to .net. Yes, that's how we say it, .net. And that's where you can get the either the .NET Core SDK, that you can use on whatever platform you happen to be developing on, whether it's a Windows machine or a Mac. Or if you happen to be on Windows and you like using Visual Studio, you should also get the .NET Core tooling for Visual Studio. And that'll give you templates and a debugging experience within VS. Our docs are at docs.asp.net. And of course, our source code is available at GitHub in the ASP.NET org at github.com/asp.net. We also have a lot of really great samples there as well that you can look at. This is what ASP.NET Core looks like in a nutshell. On your left-hand side, at the bottom, you see we have the existing .NET framework. This is a Windows component. It has lots of mature and great functionality in it, but it only runs on Windows. On top of that, we have system.web.dll, or ASP.NET 4.6, and a variety of application frameworks that we built over the years on top of system.web, like web forms, MVC, Web API, SignalR, identity, and so forth. On your right-hand side, you can see at the bottom is the new .NET Core. This is our cross-platform open source version of .NET, and it runs on Windows, Mac, and Linux. That's what we've built ASP.NET Core on top of. But you'll notice that it actually sort of spans a little bit over onto the .NET Framework side as well. Why is that? This is because the ASP.NET Core is really just a bunch of libraries. It's a bunch of NuGet packages. We have cross-compiled these packages, these libraries, so that they can run on either .NET Core or on the full .NET Framework. And that's important. The .NET Core is core. Its API surface area, in order for it to be factored as a set of packages, like the whole stack is with .NET Core and ASP.NET Core, the APIs had to be, shall we say, modernized. They had to be decoupled a little bit, which means that it's not binary compatible with existing binaries that you've built for the .NET Framework. So you do generally have to compile specifically for .NET Core. The API surface area is also somewhat limited compared to the .NET Framework, but that is rapidly changing. The .NET team is very rapidly fleshing out the set of APIs that are available in .NET Core, and we expect to have actually a really great compatibility experience going in the months ahead. But you can run your ASP.NET Core app on either .NET Core, which will give you cross-platform, or you can run it on the full desktop framework, on the .NET Framework. And that gives you better compatibility in terms of your existing binaries. So if you have either third-party dependencies or your own assets that really only run on the .NET Framework today, that's fine. You can still use ASP.NET Core and get that binary compatibility, albeit on Windows. And then on top of ASP.NET Core, we have our new web application model, ASP.NET Core MVC. Now, what do you get with ASP.NET Core? So there's a completely new hosting model, and it's completely decoupled from IIS. You can host your ASP.NET Core apps, like any type of ASP.NET Core app, whether it's a service or your web UI in whatever process you'd like. They're basically just a console app. We have a new server that comes with ASP.NET Core. It's a managed server that we call Kestrel. A Kestrel is a small, fast bird, if you don't know. Kestrel is actually built on top of the same native core that is used by Node.js, libuv, and it's very fast and very lightweight. The hosting model has a new model for defining the startup logic for your application, so there's a new startup model. We have a completely new HTTP request handling pipeline that's made up of components that we call middleware. And middleware are completely asynchronous, very lightweight. And we provide you a bunch of middleware out of the box. We have middleware for routing, authentication, static files, diagnostics, error handling, core, session, localization. You can build your own middleware and plug them into the stack. And we're also, of course, continuing to build new ones. We have middleware that are in the pipeline. We have URL rewrite middleware that's coming, response caching middleware that's coming as well. Dependency injection is built into ASP.NET Core. And this is great, because this means that it's really easy for you to express your dependencies in your middleware or your controllers, and then be able to easily test those components by just mocking out those dependencies. ASP.NET Core comes with a built-in IOC container. It's a very simple container, just meant to bootstrap the system. If you're not super passionate about DI, then that container probably will suit your needs. If you have a particular container that you love and you want to use it instead, that's fine. You can easily replace the built-in IOC container with your own, whether that's AutoFac or structure map or whatever. We have a new configuration model, which, as I said earlier, is environment aware, so that you can have configuration settings that are picked up from your current environment. We have there's a logging framework that's built throughout the system, so it's really easy to get diagnostics data throughout the stack. And then lastly, we have our application frameworks, ASP.NET Core MVC. We have support for identity, doing user management and user profiles. SignalR is available in preview, but it is being rapidly worked on right now and should be coming soon. A word about the application frameworks. If you look at ASP.NET today, we have a sort of a siloed model for how you build apps with ASP.NET today. There's a variety of different application frameworks that you can choose from when you're building on top of system.web. And they all they work great for the specific needs that they were built for, but unfortunately they're siloed and they don't share a lot of functionality that you might expect. Like, for example, web pages and MVC, they both share Razor as their view syntax, but that's all they really share. Like, the HTML helpers are completely different. MVC and Web API, they share a lot of concepts. They both have controllers and actions and filters and model binding and DI abstractions, but they actually share no code at all. And there's reasons for that. When we built Web API, we wanted Web API to be decoupled from IIS and systemweb.dll so that you could host it in your own process. MVC was already tied to systemweb and IIS, so Web API couldn't take a dependency on MVC. But this causes confusion. People will ask us, like, I wrote a filter, why isn't it working in my Web API? Oh, I accidentally used the abstraction from MVC. And it also creates duplication for us. Like, when we want to ship features to you, we end up often having to implement them twice, like once for MVC and once for Web API. So we'd like to fix this with ASP.NET Core. And so we're creating a single unified web framework for doing both Web UI and Web APIs. What does that look like? So ASP.NET Core MVC gives you one set of concepts. You can do UI, you can do Web APIs, you can do content negotiation, you can do Razor. It supports .NET Core, of course, because it's built on top of ASP.NET Core. You can run it in IIS, you can run it self-hosted. It deeply integrates with the DI system in ASP.NET Core, so you can do DI. You can inject dependencies into your controllers, into your filters, even into your views. And then on top of all that, we've even added new features to the stack. One of my favorites is tag helpers, which is a really simple way to associate some server-side logic with a tag that you're rendering in your view. And we'll take a look at that today. OK. So that's your brief 15-minute introduction to what ASP.NET Core is all about. But of course, it's much easier just to look at the code. So let's look at the code. All right. So let's get started with ASP.NET Core together. And you should do this. If you haven't done this yet, it literally will take you 5 minutes to get started with your first .NET Core app and your first ASP.NET Core app. What you want to do is, like I said, you're going to want to go to .NET, okay? And that's where you're going to get .NET Core. You're going to want to pick .NET Core, and then depending on which OS you're on, Windows, Mac, Linux, doesn't matter. If you want to do it in Docker, that's fine too. You're going to want to install either the .NET Core SDK, or if you're on Windows, you can get the .NET Core tooling for Visual Studio. All right, so you can install that. I've already done that. And so if I now go to the command line and I type .NET, this is the executor and also the native host that comes with .NET Core. And I see, yeah, I've got .NET Core on my machine. Okay, so that looks good. Let's create our first .NET Core application. I'm going to create a new directory. Let's create Hello World. We're just going to do Hello World really quick. I'm going to change this directory so to create my first .NET Core app, I'm just going to do .NET new. And that'll create me the basics of an app right out of the box. Okay, says it created something. If I do a directory, yep, look like I got a couple files. Now, I'm going to use my favorite text editor for dealing with .NET Core. I'm not going to use VS, full VS yet, but I am going to use Visual Studio Code, which is a simple, lightweight text editor and has some nice features when working with .NET Core apps. It's cross-platform, so if you're doing these same steps on a Mac, that's fine. This will still work for you as well. I'll also show you all of the command line versions of everything that I do in Visual Studio Code. So let's start VS Code and take a look at what we've got. Okay, so we've got, let's make it a little bigger, program CS, okay. That looks like your normal Hello World console app. I got just a couple notifications from VS Code here. What are these? So the first one here says that there are unresolved dependencies from my project.json file. Please execute the restore command to continue. And what is that? Well, you notice I'm getting all these red squigglies as well, like it can't find some of the types. Everything, remember, in .NET Core and ASP.NET Core is a package. It's a NuGet package. If I look at this project.json file, this is the file that is just a simple chunk of JSON that expresses all the packages that my app depends on. Now, this is Hello World, so it depends on almost nothing. The only dependency it really has is the .NET Core app package. But whenever you have a dependency in the .NET Core world, you need to restore those dependencies onto your machine. You need to pull down the packages and make them available to your app. So let's do that. I could do that right here from VS Code, but I want to show you how you do it from the command line first. So I'm just going to do .NET restore. And that's going to go and grab all of the dependencies that my application needs to run. There, it's done. By the way, a trick, if you ever, well, before I show you the trick, notice that after I run .NET restore, I've got a new file in my project. This is project.lock.json file. What is this thing? This is a serialized representation of the entire package graph, the dependency graph that this app needs. So it's got all the dependencies for all the system.star packages. And if you want to put yourself to sleep at night, this makes for a great read. Just go ahead and browse through that guy. So yeah, if you are curious where the packages are coming from when you run a .NET restore, one trick is to do .NET restore -v information. And this will just do a normal restore, but it will also tell you which NuGet.config files are being used to decide which feeds it should query for the packages. Most of your packages are going to come from the official NuGet.org feed. When you install the packages using, when you install the Visual Studio tooling, it'll give you like a local version of those packages as well. And then I have my own little feed that I've set up. So that's how you can find out where your packages are coming from. Now, when you restored them, where did they go to? Like, where are they on your machine? They're all put into your user profile when you're doing .NET Core development. So if I go to my user profile, there's a .NuGet folder, and there's your packages. So you can see I have lots of package goodness inside of on my laptop. Okay, that's where all your packages went. Okay, so we've done a restore. Now I want to run this app. How do I do that? So to run your app, you can just do .NET run. And that actually does two things. It'll first build your application. It'll produce a binary. It actually is using Roslyn under the covers. And then it will just use the .NET executor to execute the entry point of your app. So .NET run, we should see those two steps. Look, it's compiling, it built, and then hello world. Okay? So that's your first .NET Core app. You should all do this. If you haven't done it yet, go download, install .NET Core SDK, create your first .NET Core app. It's fun. It's really easy. All right, we can do these same steps also from Visual Studio Code. So Visual Studio Code has some nice features for these things. I can close that one. Notice that the second notification it gave me is it's saying that there's some assets that it needs so that you can build and run from within Visual Studio Code. All right, let's go ahead and add those, and it's going to add a little folder here with some VS Code gobbledygook. But what that enables, which is really nice, is now I can add things like breakpoints from within VS Code. Remember, this is cross-platform. You can do this from your Mac. I can go to the debug tab, and I can actually now run this app from within VS Code. And if all works according to plan, I should see that breakpoint getting hit. It's starting the debugger, it's attaching, boom. So we hit a breakpoint from VS Code. We can continue on our merry way, and we should see hello world, and that worked. Okay? So that's some nice things you get from VS Code. All right, that's our brief introduction to .NET Core. And that we want to do ASP.NET Core development, though, right? So let's make this now an ASP.NET Core application. Now, the first thing you got to realize is that an ASP.NET Core app is just another console app. ASP.NET Core is just a bunch of packages. It has a hosting model, it has a server, but you just wire that up in your whatever process you want, and you've got an ASP.NET Core app. So let me, first we need to add the ASP.NET Core packages. So I'm going to go into my dependencies node, and I'm going to add Kestrel. Remember, that's our managed web server. So Microsoft ASP.NET Core server Kestrel. That's the Kestrel package, and I'm getting some nice IntelliSense here on the versions that are available. I'm going to grab 1.0.1, that's the latest version we shipped just about a month ago. And I'm going to save, and VS Code detects that I need to restore packages. I could go back to the command line and do it there, but since VS Code is helping me out, I'm going to let it do it. So we pull down Kestrel, restore is complete, good. All right, so now we need to set up ASP.NET Core hosting. To do that, we're going to create a host using the web host builder, okay? I think I need some using statements here. Hopefully VS Code will help me out with that. It does, awesome. Okay, so what are we gonna do with this web host builder? First, we're gonna tell it which server we want to use. And we're gonna use Kestrel, that's the one that comes out of the box. You don't have to use Kestrel. If you want to write your own HTTP server and plug it into ASP.NET Core, you're more than welcome to. That would be great. You could share it with the community. It could be the next hot HTTP server. We actually are shipping another one for an upcoming release. We have a new server that is based off of HTTP sys in Windows. It's a Windows-only server, but we call it our web listener server. So if you want to take advantage of HTTP sys features on Windows, we're going to make that available to you. But I'm just going to use Kestrel. Okay, and now I need to configure what I want my app to do. Configure is the verb. Configure, I can just put a little delegate here that defines what my app does. You can see it says I need to define an action that takes an iApplication builder. So that's what this app variable is going to be, is that iApplication builder. And this app is going to be super simple. We're just going to do ASP.NET Core hello world. It's going to take in the request. Request comes into the pipeline. And it's going to just write out something to the response, write async. Everything in ASP.NET Core is async. Hello from ASP.NET Core. Okay, and I probably need to resolve some namespaces. VS Code's going to help me out with that. Good. Oh. Try again. There we go. All right. So that's my app logic in that configure method. I'm using this app builder to say, what do I want the request pipeline to look like? And I just have one little thing in there that just says, returns hello world to the response stream. Okay, now we need to build our host. So build, and that's it. All right, now that we have a host, we need to get it going. Tell it, start listening for requests. So I'm going to call .run on the host. And if you missed it, so it said, runs a web app, blocks the calling thread until the host shuts down. That's what we want. Okay? Let's hide that. And that's it. That's our first web app using ASP.NET Core. It's about 10 lines of code or so. So we save that, and let's run it. I'm going to run it from the command line. .NET run. It's going to build without errors. That's good. And it says we're hosting in production. This is our content route path. We'll talk more about that in a second. And we're listening on port 5000. Hit Control-C to shut down. OK, so let's now open an impartial third-party browser and go to localhost 5000. All right, there. So hello from ASP.NET Core. So it's pretty simple. Okay. So hopefully that gives you an idea on just how you get started and the things that you need. I'm going to shut down the server by hitting Control-C. And at this point, so this is good for simple, just quickly getting started or doing hello world demos. By the way, the steps I just followed, if you want to follow along with them, you can go to ASP.NET Get Started. And the same steps that I just did, they're all right here. You can just do them yourself, and you should. Everyone should go try it out. There's actually a better way, though, to define your application's startup logic. You can define it as a class, and so I'm going to do that next. But at this point, I think I'm going to transition over into VS so you can see the Visual Studio tooling. All right, I think I should. Let's close this guy. All right, so I'm in Visual Studio. I've already installed also the .NET Core tools for VS, and I'm just going to do File, New Project. All right, so web is what we want, and let's make this a little bigger so you can actually read it. And we've got a few options here under web. We have the existing .NET Framework System Web, set of technologies, web forms, MVC, Web API, and so forth. And then we have these two ASP.NET Core options. The first one says, I want to run on top of .NET Core. Okay, so that will be an app that can then be taken cross-platform if you want to. You can develop on Windows and even publish it to a Linux machine if you'd like. The second option is, I'd like to write an ASP.NET Core app, but I want to run it on the full .NET framework. And that allows you to reuse existing binaries that you have or third-party dependencies that don't yet support .NET Core. Many third parties are rapidly adding .NET Core support, but in some cases you might not have that yet, and so that could be an option for you. I'm going to use .NET Core, and let's just create an empty web app. All right, so hopefully a lot of things in this app will look very familiar based on what we just did. Let's see. OK, so first of all, while VS creates a project, as soon as it's done creating, it's going to kick off a restore for me. And I can actually see the output of the restore by clicking the output link. And this is restoring the packages that my app needs to run. Now let's look at program.cs. So this should look very familiar. There we got our web host builder, and we're saying we're using Kestrel. We're building it and running the host. There's a couple extra concepts in here, and I'll go through those real quick. The first is that this idea of a content root. The content root of your ASP.NET Core app is the path where all of your app's stuff lives. Like your static files, your JavaScript files, your CSS, your HTML files. Those generally will be served from a path that's relative to your content root. That path actually has a special name. We call that the web root. And by default, the web root is www root relative to wherever your content root path is. Okay? Now you can actually change either of those things. If you want your content root to be someplace else, you can tell the host, I want you to find stuff at this other location. By default, the content root will actually be the location of your application binary. So you remember when we built the app, there was that bin direct. Did I show that? I don't actually remember if I showed that. Let me go back. OK, great. So when you build the app, and I didn't even actually do this independent. I was doing .NET Run, which does both a build and a run. If you just want to build your application without actually running it, you can do that by just doing .NET Build. That just does a build. When you do a build, you will get a bin directory. And that's where your application binary lives. And this is your default content root for your app. And there's a couple interesting things in here. There's the DLL that got built, the PDBs. There's a couple of JSON files that are used at runtime. This first one is a dependency file that gets, it's sort of like a mini version of the project lock file that we saw earlier, but used at runtime. These are the runtime config files. These have settings that can be used by the runtime, like I think if you want to turn on server GC, I think it will show up here. For the most part, you can ignore them. They're advanced concepts. But this is where your content root will live. By the way, during development, all your dependencies are living in your user profile NuGet folder. When you're ready to actually take this app and publish it to production, you should run a .NET publish command. Because you want to take all the dependencies out of your NuGet package folder, collect them together into a single directory, so then you can move them someplace else. That way, when you're publishing your app, you don't have to run a NuGet restore on your server to get all the things that it needs to run. So a couple things first. If I want to run a built app directly, you can just point .NET.exe directly at the binary that you want to run, and that will just run the application. As you just saw there, start up my ASP.NET Core app. If you want to publish, we just do .NET publish. And that will collect up all the dependencies and put it in a single folder. By default, it looks like it put it under this publish directory in the bin directory. Let's look at that. Yep, there it is. And now you'll see there's a lot more binaries in here, right? Like all the binaries needed from the NuGet packages that you restore got collected together into that publish folder. And you can just take that folder now and copy it wherever you want to go. Okay? A couple extra concepts there. Okay, so content root. That's where your app will find its stuff. Now, because by default it's the directory of your app binary, well, usually my project, like the stuff that's in my source control, is not going to be living down in bin, right? It's going to be a couple folders up. So as a way to handle that issue, most of our templates will actually set the current directory, wherever that is, for the content root. That way you can leave your static files and your MVC views right there in your project, and then at runtime it can still find them. So that's what this is doing. It's setting the content root. If you want to set the web root to be something other than www root, you could do that as well. You could say use web root and set it to, I don't know, like foo or whatever. That's possible. Okay? Use IIS integration. What is that? Remember, ASP.NET Core apps are just a console app, but we highly recommend that you run them behind some sort of production web server, some sort of mature web server that's really ready for internet-facing traffic. We don't actually recommend taking Kestrel and sticking it directly on the internet yet. We're rapidly in the process of hardening Kestrel and making it stable enough and ready to do that. But right now, it's missing a few things like that you would really need to make sure that it can handle any sort of malicious traffic that could be thrown at it. So for the time being, we recommend that you run Kestrel behind something like IIS, or you run it behind something like on Linux, you could use Nginx or HAProxy, some other mature web server. With IIS, the way that's done is we provide you a native module that we call the ASP.NET Core module. And all that module does is when a request comes in, it goes off and fires off a process, and whatever process really that you tell it to start. In this case, we always tell it to start .NET.exe and run my app, and that will then fire up Kestrel inside that process. And then the core ASP.NET Core module will take any requests that it receives and just forward them along to that process. And there's a handshake that has to happen there so that the process can receive the request and know that it's not coming from someplace else, someplace other than IIS. That's what this use IIS integration line is doing. It's enabling that handshake. And I'll go over in more detail exactly what that does later this week. But for now, you can just know that if you're running behind IIS, it enables that integration. If you're not using IIS, this line of code is actually completely benign. It doesn't really do anything at all. So you can just leave it there, and that's why we put it in. And then lastly, here's the normal pattern for defining your startup logic, which is to use a startup class. So instead of saying .configure and having a bunch of delegates in line in your hosting logic, you can define a separate class that defines what your application actually does. So let's now go take a look at startup. Okay, so there's our configure method. And it takes an application builder, just like we saw before. It also has the option of taking additional parameters that are services provided by the hosting layer. So for example, if you want to know, well, what's my content root at runtime, you can use this iHosting environment service to know things like, what's my content root? What's the web root folder name? So you can resolve paths and those sorts of things. You can see it's also getting access to a logger factory. There's logging plumbed throughout the system. And then in here, we define our request handling pipeline. This is where we're going to use middleware. The request handling pipeline is just a bunch of middleware, and they're ordered. Each middleware gets a chance to see the request and decide what it wants to do with it asynchronously. And this app has a few middleware in it. First, it's just setting up some logging. That's not middleware. But the first middleware is this one, where it's saying, I would like to use the developer exception page. And it's in this if block that says, but only if I'm in the development environment. So what does that mean? The developer exception page, maybe you all are familiar with the yellow screen of death, right? In ASP.NET, something bad happened on your server, and when you're in development, there's this nice feature where there's something in the ASP.NET pipeline that will catch that exception and then render details about that exception to HTML, so you can actually see it in the browser, so you can figure out what went wrong. Otherwise, you would just get 500 and no details, and that can be really frustrating. So during development, that's a super useful feature to have. But when you go to production, you don't want to be telling the whole world about the call stack of your entire app implementation. So that's a feature you really only want to use in your development environment. So this use developer exception page middleware is a piece of middleware that does that same task that the yellow screen of death used to do. It catches the exception and renders some nice HTML so you can see details about the exception. Let me show it to you real quick. If I run this app without changing anything, I'm just going to get hello world like we had before. Okay, there's hello world. And now if I have an oopsie in my run method down here, okay, and then I refresh. Now, I'm not actually building here. One of the nice things that the Visual Studio tooling does is it has a file watcher that, oh, I need to throw it. There we go. It has a file watcher that will watch all the C# files in your project, and if they change, then it will actually tear down the process and rebuild it and get it starting again. So you don't have to keep doing build in F5, you can just refresh in the browser. It's pretty nice. And so this is the blue and gray screen of death in ASP.NET Core, right? So we get some nice details about the exception, where it occurred. You can see details about any cookies or query string parameters, the headers on the request. It's pretty nice. It's not too bad. One nice feature that a lot of people don't notice is down here at the bottom. Often you need to copy the stack trace from the exception from this page and post it on Stack Overflow or put it in a GitHub issue so you can tell us about it. If you just click this link to show the raw exception details, here's something that you can just conveniently copy and paste into a bug. Okay, so that's kind of useful. Now, this page should only show up when I'm in development. Now, what does that mean? Well, in ASP.NET Core, there's a first-class notion of the environment. What environment are you in? And that's defined by the host. If we go back to our hosting layer, and I say here, use environment, I don't know, staging. There, I've just changed my environment. Okay, and now I refresh the browser. I'm no longer in a development environment. I'm in some other environment. Now I just get a 500. I don't get any details because I'm no longer in that development environment. This is development check is seeing what environment are you in and only adding this middleware to the pipeline if you're in the correct environment. Now, statically hard coding what environment you're in into your hosting logic is probably not that useful. That's why there's also an environment variable that you can specify to say what environment the app should be currently in. And actually, that's how Visual Studio specifies that when you're running in Visual Studio, you're in development environment. If I right-click on the project and look at its properties, Visual Studio has this nice thing that are called launch profiles, which when you hit F5, these are the settings that you want to use when you actually run your app. This app is set up to use IS Express, and you'll notice it's also set up to specify the ASP.NET Core _ environment variable. And it says, I'm in development. If you don't specify anything, if you don't say what environment you're in at all, we'll assume that you're in production. So if I were just to delete this or just change this now to, let's first, just so we can see that something changed, let me make sure we're getting the exception page back. Yeah, okay, so we got the exception page back, and now if I go into back to my properties, they should still be here, and I change this to, I don't know, demo. I'm in the demo environment. Then I go back, refresh. Oh, I have to rerun the app because it doesn't detect changes in your project properties. It only detects them in the C# files. Now I'm back to a non-development environment, okay? So that's your environment concept in ASP.NET Core. You can define your pipeline based on what environment you're currently in. Where you get the environment setting from, there's a variety of ways that you can do it. Like as you saw, you can actually, so the question was, is it configurable what environment you're in? Like, do you have to use the environment variable, or are there other ways? You can, of course, code it in the hosting layer. You can also tell the hosting layer that you want it to read from the configuration model any of the settings that are used by hosting, including what environment it's running in. And I'll show what that configuration model looks like, but that configuration model allows you to specify the environment using like a file on disk. You could create a custom config provider that reads from a database if you wanted to. You have complete flexibility on how to specify that. Out of the box, we do give you the environment variable because we think that's sort of a convenient way to do it. Good question. Okay, so that's our first middleware in the pipeline, and then there's a middleware. This really is like a little inline middleware that just returns hello world. Let's add some more middleware to this application. Let's turn on static files. Now, you might say, turn on static files? Like, why do you have to turn on static files? Well, remember, everything in ASP.NET Core is completely modular. If you want it, you have to add it. If you don't want it, then don't add it. But in case of static files, it's not there unless you actually enable the feature. So the pattern is that first we need to add a package, and then we need to add the middleware. So to add the package, I'm going to use the NuGet package manager from within VS. It's kind of nice. Get a little UI. And I'm going to say I would like static files. And it's this one. This is the package I want. Yep, I'm going to install that. And it's going to kick off a package restore to bring down the package. OK. And now, I just want to show that if we open project.json, this project.json has all sorts of stuff in it now. It had the diagnostics package. That's what brought in the exception handling page. It has the IS integration package, Kestrel, some stuff for logging. And you'll notice now it has the static files package as well. All that NuGet package manager did was it edited project.json to add this line and then kicked off a ran .NET restore. That's all it did. So you can just as easily do that from the command line. But the tooling's kind of nice. All right, so we've got the package now. Now we need to add it to our app. Let's go back to the development environment before I forget. So let's say app.use static files. OK? I don't have any static files in this app yet. And actually, initially, I'm going to comment this out just so we can see it light up. In my www root folder, this is the folder that the static file middleware looks at when it's deciding whether or not to serve up static files. I'm going to add just let's add an HTML page. Let's call it index.html, and let's put some HTML in here. I'm so ecstatic. Get it? Ecstatic? Never mind. All right, whatever. It seemed funny last night at 1 a.m. All right. So we've got a static file. OK, let's run the app. Now remember, if we look at this pipeline, this request pipeline basically always returns hello world at the end. So if nothing does something with the request before it gets to the end of the pipeline, it's just going to return hello world. OK. Now if I try to go to index.html, I still get a hello world. That's because I haven't yet enabled static files. So I'm going to enable it, and if I refresh now, I'm so ecstatic. Yes. OK. So now we've got static files. Now, often people assume that there's some notion of a default HTML file, right? Like index.html often is treated as a default file. That's obviously not working yet in this app. If I go to just the root, then it's not picking up index.html as the default. But if you want that, you can enable it. Again, it's just something you add to your request handling pipeline. So I can say app.use default files. And what does that do? That will look into your web root and see if you have a file that has a file name that looks like a default file. If it does, and the request is to the root of the app, it will actually modify the request URL to have that default file be the request URL. And then the static file middleware picks that up and says, oh, you want me to serve up index.html. It's a default file. So that's what this is doing. And so now if we refresh, I should see I'm so ecstatic. There we go. OK, so that's enabling static files. So that's middleware. Middleware, you add packages to get middleware available to your app, and then you use them in your configure method. And we have lots of middleware for routing, middleware for authentication. This is the static file middleware. OK, cool. What else do we want to show you? Oh, let's talk about logging just really quick. Yeah, and we've talked about environments already. So logging is available throughout the app. It's a hosting provided service. So there's our logging factory. You can see that this app is setting up console-based logging. That was one of the packages that was in project.json. There's the console logger. So this will just write the standard out, right? That's not super useful when you're running behind IIS, because you don't normally get to see the console output when you're running from IIS. So I'm going to add another logging provider. I'm going to add a debug logging provider. Let's save that. When I edit and save the project.json file in Visual Studio, it automatically kicks off a restore, which is great. And let's go back to startup. And now we're going to say logger factory.add debug. And this guy will enable like trace.debug debugging so that when you're running under the debugger, it will show up in the output window in VS, which can be really useful. You don't have to do that. Like you can actually use a different launch profile and say, I don't want to run this app during development behind IIS. I just want to run it as a normal console app. That's what I just switched there. So if I run it like this, This will just pop up a console and run it as a console app. And you can see now I actually get to see the console window, and I can see the logging output. Like I can see things like the request path to the default index.html file. I can see when requests are started and when they're ended. Okay, so I end that. If I go back to IS Express, I got a bunch of windows open. Let me close all these guys. All right, now if I let me add my own logging statement here as well, just to show that you can do this too. So logging factory, logger factory dot create logger. Let's create demo. And let's log information level stuff. I'm running. Okay. Now if I run this under the debugger, hit by hitting F5, and if I look in my output window, so now I'm seeing a bunch of debug information. All the symbols are getting loaded. But intermixed with all those symbol loading, you can see the ASP NET Core logging data. So there's, like it's saying, a request got started. And somewhere in here, I would expect to see, oh, so we hit the static file middleware before it made it to that run methods. But if I go to like foo, now we see request got started, and there's demo I'm running showing up in the logging output, and there's the end of the request. Okay, so that's logging. There's a bunch of providers. If you want to use like Serilog or Log4net, there are providers for those logging frameworks as well. We're actually building a logging provider that integrates with like Azure, the Azure logging infrastructure on Azure App Services. Okay, so we've seen logging. I think we're ready now to graduate from the Hello World apps to something a little bit more meaty. So let's do file new project. And let's do another web app, but this time we're going to click all the buttons. We're going to say I want a web app, I want individual user accounts. So this is going to give me a ASP.NET Core app that has MVC, it has identity, it's using Entity Framework Core for storing the identities and storing data. A little bit of everything. So now it's restoring all the packages. If we look at the hosting logic, that looks exactly the same. There's no change there, right? That's just setting up the host and getting Kestrel running. If we look at startup, we've got all sorts of things going on in this startup class. So first of all, in the constructor, we're waiting for all the packages to restore so those red lines go away. In the constructor, there's that configuration model that I mentioned previously. So it's a very simple, lightweight model. The way the configuration model works is it has an ordered set of providers. We have providers that we give you for reading name-value pairs from JSON files, from XML files, from ini files, from environment variables. So here you can see I'm using the configuration builder to say I want to read config data from a JSON file. It's appsettings.json. That's in my project, and this is just where it's getting the connection string from, and also some log settings. Okay, so that's just a JSON file in your app. It's also saying if I happen to have a environment-specific JSON file, then I want those settings to override the previous guy. Okay, I don't have that in my app, but if I had defined appsettings.development.json, then that would work. This one's cool. When I'm in the development environment, it's using the user secrets config provider. What is that? Well, one of the common fails of modern day app development is that we like to use configuration for things like app secrets, and then often those configuration files make their way into source control, and often source control has more people have access to that source control than you might expect. For example, if you push it to GitHub, it's very easy to go searching through GitHub and looking for people's connection strings and Facebook app IDs and that type of stuff. So what we did in ASP NET Core is we created a config provider that will instead look for config data from someplace other than your project. In this case, it will just pull it from a JSON file that sits in your user profile. So that's a really convenient place to stick things like secrets that you're just using for development. They're not your production secrets. They're just secrets that you want to use in development, but you don't want to accidentally check in to your source control. They're someplace outside of your project. If you want to know where that file is, there's actually a little VS gesture. You can right-click on your project and say, manage my user secrets, and it'll open that JSON file. And you can do things here like, something super secret. And put your super secret password here, that type of stuff. And then these values would then get picked up by the configuration model. Okay, so that's kind of fun. And then reading from environment variables. So this enables the config system to be environment aware. Like that JSON file that I had, the app settings.json, where I've defined this project template's defined the connection string. Well, when I go into production, I want to use the real production database, right? So one way you could do that is you can just provision an environment variable in the production environment that specifies the real connection string, that has the right config key, and then the config model will just pick that up. It'll just override your development settings. So that's one way you could do that. Then builder.build creates the actual config object. When you want to actually get a config value, you just do brackets and put your key here. So super secret would go there. Okay. So that's the new config model. It's environment aware. It's pretty nice. We use it in various places in the template. Like here, we're using it to get the connection string, using a little helper method. Down here, when setting up logging, we're using config to get the log settings. It's just grabbing that whole section about logging and handing it off to the add console method. And you can use it within your own app. OK, so that's configuration. I think it's time to talk about this configure services method and talk about DI. So configure services is the method in startup that you use to register your application services. We've seen a bunch of services that were coming from the hosting layer, like this iHosting environment service or the iLogger factory. Those are services that are just available by the fact that you're an ASP NET Core app. But your application probably has services as well, and you use the configure services method to register them. So for example, this template is registering its DB context, like the ND Framework core DB context as a service, so it's available through DI throughout the application. It's registering the ASP NET Core identity services, like I think it's the user store and those types of things, so that they're available throughout the app. It's registering the MVC services, like how it does action selection, how it finds the controllers, what formatters you want MVC to use. Those are all configured services, and they get added like that in your configure services method. And of course, you can add your own services. Like here, we're adding a service for an iEmail sender and one for an iSMS sender. These could be used for things like two-factor authentication or for account confirmation. And once you've done this, once you've registered your services in this way, they become available via constructor injection in your middleware, in your controllers, in your filters. Let me show you an example. If we look at the account controller in this template, here's its constructor, and it's taking in a whole bunch of those services, like the user manager from identity, sign-in manager. There's the iEmail sender and the SMS sender that we had seen as well. There's the iLogger factory from the hosting layer. You can get those here as well. Okay, MVC, ASP NET Core MVC is aware of DI. You can inject stuff into your controllers. There's ways to do it into your filters. You can even do it into your views. Like if we look in the login view in this app, at the top here, you'll see there's this new Razor directive, @inject. And what this does is it says, on my Razor page, I would like to define a new property. And the property is of this type, and this is the property name. And I would like you, Razor, to please inject the service of this type into this property so it's available to my page. So that's how this particular page is getting access to the sign-in manager from Identity, is using this new @inject feature in Razor. So that's kind of cool. OK. And then if we look in the configure method, this is our request pipeline. Now there's a whole bunch of additional middleware that we haven't seen before. In addition to the developer exception page, there's a special developer error page for the database. This guy lets you easily run migrations if you haven't done that yet. Like if you forgot to run EF migrations, this thing will tell you to do it. You can wire a browser link. If you're not in development, like you're in production, typically then you want to provide that like the oops page. You know what I'm talking about? Like, you go to a server and it's blown up and they give you this nice page that says, I'm sorry, we're not available right now. Please try again later. This piece of middleware allows you to set something like that up. When this guy sees an exception, it just redirects the request up the stack to this path that you specified. And in this app, that path happens to be just an action on my home controller, which renders some view someplace. I think it's under shared. Yeah, there it is. Just renders some oops page that says something bad has happened. OK? And that will show up in production as opposed to in development. We've set up static files. Identity is setting up login. We're not going to go through identity here. And finally, we get to MVC. We do want to talk about MVC. OK, so MVC is built on top of routing middleware. It is built on middleware. There's middleware happening here. There's a routing middleware that comes with ASP.NET Core. It has support for the template style routes that if you've done MVC development before, that should look pretty familiar, where you define a template. It uses the similar conventions that MVC used in MVC 5. So you have a controller name, you have an action name. When a request comes in, you pull out some values from the request URI to specify what controller you want to go to, what action on that controller, and then you go and call that action on that controller. Some nice things, though, about routing in ASP.NET Core is that we now support this nice compact syntax right within these the route table routes. Like you can say, I want a default value by just saying equals blah. This is a syntax we've supported with attribute routing in previous versions of MVC, but now you can actually do it directly within your convention-based routes. Similarly, if you want to define like optionality, you want to say a value in the URI, a pass segment is optional, you can just say question mark. Before you had to define like some crazy anonymous object and use some special marker value and blah. Now you can just put it right in your template, which is pretty cool. You can do things like inline constraints. Like if you want to say this route should only hit if this ID is an integer, you can do that. It's colon and then the name of the constraint that you want to use. And there's a whole bunch of built-in ones. So this one would say that ID has to be an int. Okay? So that's convention-based routes. If we run this app, I'll just go ahead and run it so you can see what the app does. What did I do? Question mark. Thank you. Whew. Glad someone's paying attention. I was like, why does everyone keep saying question mark? Question mark what? Yeah, no, that's what's getting me nervous. Okay, so there is our just a normal template, and you can register users. You can log in new users and so forth. This is rendering standard MVC views. If we go to the home controller, you may have saw it briefly before. This is just returning view. We've got a bunch of views inside of the views folder. So that's standard MVC web UI, and that's virtually unchanged. If you have an MVC app today and you want to port to ASP.NET Core, for the most part, you should be able to copy and paste your controllers and views into an ASP.NET Core app, and those controllers and views you should pretty much not have to change at all. You may have to change the namespace. Like instead of system web MVC, the namespace is now Microsoft ASP NET Core MVC or something like that. But other than that, the code is pretty much the same. But one thing that's different is now you can do web API logic in the same model. It's the same controller model. It's the same underlying infrastructure. So for example, on my home controller, let's define a little web API. I'm going to do actually let me define a little model type. So let's call it a public class value prop int ID. Let's give it some sort of text value. There, that's just a simple little value. And we're going to have a little web API endpoint that returns a value. And it's going to take an ID. And let's return a new value. And the ID, let's just copy the ID in, and then we'll use a little bit of string interpolation here. Value ID. Okay, that's just C#6 syntax. All right, good. Now you can do attribute routing directly within ASP.NET Core MVC. So I'm going to put an attribute route on this action and say that this guy should only respond to GET requests to API/ID. No, API/value/ID. That would be better. Okay, great. Okay, did I forget something? Thank you. Text equals value. Okay, good. All right. So now I should be able to go to API/value/123. It doesn't really matter. And there we go. We get some JSON. So I'm returning just an object. That object will get formatted using the set of formatters that you've configured in the system. Very similar model to what we had in Web API with ASP.NET Web API. By default, the JSON formatter is there. If you want XML, you can add it. If you want to add your own formatters, you can do that. Okay, so that's attribute routing, doing Web APIs with MVC. Often with Web APIs, you want to have It's nice to have some metadata about your web API and maybe a help page that describes your endpoints and what they look like. We don't have metadata support built into ASP NET Core out of the box, but there's a nice standard out there. It's called Swagger, which is a fairly popular metadata format for web APIs. And there's a great community package that you can use to add Swagger support to your APIs. Let me show you that really quick. So I'm going to do Manage NuGet Packages. The name of the community package is called Swashbuckle. So we're going to add some Swagger with Swashbuckle. So that's pretty cool. All right, let's see if we can find it. I want browse, not installed. There it is. I'm going to install this guy. So Swashbuckle will give you two things. It'll give you both the Swagger JSON representation of your API endpoints, and it will also give you a nice little UI that you can see your API. You can actually test it within the browser. It's pretty convenient. All right, so it's restoring. And then while it's doing that, I want to go to Startup. And we're going to add Swagger to our app. So first I'm going to add the services that Swashbuckle uses. So I'm going to say services.add. So you add services, OK? You use middleware, you add services. So those are the services that Swashbuckle needs to function. And then down here, we'll add some more middleware to our pipeline. We're going to say app.use Swagger. So that will add middleware to the pipeline that enables the JSON metadata format. And then app.use Swagger UI, that will add the nice help page and little in-browser test client. OK? All right, I've saved that. So now I think the URIs that those guys use by default is Swagger, then v1, the version, and then swagger.json. Is that right? See? If we see a whole bunch of JSON stuff, we do. OK, so that's the machine-readable description of my little tiny API. If I want to see the human-readable version, I can go to swagger/UI. And there we go. So now we've got a little browser view. There's my endpoint, API value, the ID. It shows me the schema of the response entity. It shows me what content types are supported. I can even try it out. Like if I do 3, 2, 1 here and try it out, it'll actually run, query the API, show me the response, show me the headers. So that's kind of fun. And then you can use the machine-readable metadata format to do things like if you want to generate a client, you can do that. There are frameworks available for doing client-side generation. One of them is called AutoRest. If you haven't seen AutoRest, it's pretty cool. There's even some Visual Studio tooling for running AutoRest within projects. I think with .NET Core projects, it's not enabled yet, but you can run it from the command line. In the interest of time, I think I'm going to skip showing that, but it's pretty nice. It'll generate you a client proxy. It'll see that there's this type called value and generate you a value type that you can just use to call your API. OK, so that's your building APIs with ASP NET Core MVC. Let's take a look at some of the other MVC features in the views. There's a bunch of new stuff that's available in the views. Like if we go to, let me go back to Home and pull up About. OK, so this is just the About page. I'm going to look. This is the About page in Razor. One of the nice things with ASP.NET Core MVC is that we support C#6 syntax. So if you want to say like var me equals, Dan 27 or whatever. And then I want to use some string interpolation from within my view. That works. You can see that IntelliSense is lighting up nicely. If I save and refresh, I should see about Dan 27. Yep, so that works. So that's C#6. Everything is asynchronous inside of the views. If we look in like layout, there's a new Razor directive that you can use, which is add await. So you can await asynchronous logic. Where is it? It's right. Like for example, if I want to render a partial view within my view, that's now an asynchronous call because the whole Razor rendering pipeline is asynchronous. So you can call add await to await asynchronous logic within your views. That's kind of fun. What else do I want to show? And then tag helpers. Let's look at tag helpers. Oh my goodness. Tag helpers. So to motivate tag helpers, I think what I really need to do is first show you the way the world used to be, right? The way it is today. Do I have it here? Do I have to open? Let me open. What I'm going to do is I'm going to open the login view as it was done with MVC5. Okay? Let me think I have it. Projects, MVC5 defaults. Yeah, that's the one we want. Let's look at the login view as you would do it with MVC5. So this was hot when we shipped it. So I don't want to knock this too much. And by the way, this entire syntax is still supported. If you have this code, don't feel bad. Like, this code will still run in ASP.NET Core. We still support HTML helpers. The way you would do Razor stuff with MVC5 is you would use these things called HTML helpers. An HTML helper was just a C# method that could render some HTML. And that was great. You could do things like interact with your model through these HTML helpers. For example, here's an HTML helper that's going to generate me a form. And it'll generate a form that points to this particular action on my controller. And that's cool. There was a HTML helper for like generating a label based off of your model. Like, I want to generate a label for the email property of my model. That's all great. Where the problem starts to arise is that the way HTML helpers work is that they're C#. And once you go into an HTML helper, you are basically stuck in C# land. Now, if you want to customize the rendered HTML from an HTML helper, well, you're in C# land, so you have to somehow do that within the HTML helper itself. It had to expose some extensibility model that allowed you to add like custom attributes to the rendered tags that it outputted. So for example, this label, if I wanted to change the class on the label tag, well, you could do that with an HTML helper. The way you did it is with an anonymous object. And the convention was that the property names of that anonymous object would get put as attributes on the tag. And then the value of the property would be the value of that attribute. OK, that's fine. In this case, I want to add a class attribute. Well, remember, I'm in C# land. And class is a reserved word in C#, right? So if I want to define a property named class, well, in C# you have to escape that and tell the compiler, like, this is not class, the reserved word. This is class, just a random property name. It's just an identifier. And the way you do that, unfortunately, is with an @ symbol, which happens to also be the same character that you use in Razor to transition between C# and HTML. So that's not confusing at all. Now, this became very apparent as a problem when you really start looking at things like Angular, where you have tons of custom attributes that you're putting on tags, and you're trying to do that while using HTML helpers at the same time. You kind of start to feel like you're fighting the system. OK, so let's look at how this looks when you're using tag helpers. So here is what that same view looks like, but done with ASP.NET Core MVC. And the first thing you'll notice is that it looks like HTML. Like, I no longer see this C of C#. It looks like HTML. It's purple HTML, but it still looks like HTML. Now, this is a little VS feature that's letting me know that for each of these purple things, there is a tag helper that is recognizing that tag and saying, I'm going to do something custom with this tag. I might change its content. I might swap it out for something else. I might add attributes to it or remove attributes from it. All those things are possible. So for example, there is a form tag helper that is recognizing that, oh, there's this special tag helper attribute. This isn't an attribute that's going to get serialized down into the HTML, down to the browser. This is just something that the tag helper recognizes, and it's going to use to figure out what URL to put on that for the action of this form. And then it just removes that attribute, and then you never see it again. Here's that label again. Here I'm just saying label, and I would like it for this particular property. And these tag helper attributes, these special properties, these are little windows of C#. So like in here, I do get IntelliSense still. Like, you see that? Like, it says email. That's a property on my model. You still get that. But now, instead of like having to use that anonymous object syntax, I can just use attributes as they were intended. Like, I can define my class attribute just as a normal HTML attribute. When I hit space inside of here, I get the benefits of the awesome HTML editor that we have in Visual Studio, and can pick whatever class I want. So that's pretty nice. That's what tag helpers are. So hopefully this looks simpler, more natural way of doing your rendering logic. We have a whole bunch of built-in tag helpers. I've already shown you form, label, input tag helpers, so you can specify a property that you wanted to bind to a particular input. If we look in layout, there's a whole bunch of interesting ones in here. Here's a completely custom tag. Don't go looking in the HTML5 spec for the environment tag. There is no environment tag in HTML5. This is a tag helper. And what it's saying is, if the current environment that this app is running in, remember environments, development, production, those types of things, if that environment is development, then here's the links that I want to use. If I'm in staging or production, then these are the links that I want to use, okay? And so the environment tag helper will either render its content or not, and then the environment tag is just removed and never rendered down to the browser. That's how that works. That's the environment tag helper. There's also a link tag helper. This link tag helper in production, what it's saying is that if I'm in production, I would like to use a CDN. See that? But if the CDN happens to be down, the fallback I want you to use is this guy. I want you to go to this guy instead. And here, in fact, are the tests that I want you to use to figure out if that CDN actually correctly resolved or not. And so this tag helper will generate some fancy JavaScript that will figure out if the CDN worked or not, and then use your local version if it wasn't available. So that's kind of cool. There's an anchor tag helper for generating links. We have a caching tag helper, so you can surround parts of your view that are expensive and you just want to cache away. There's a whole bunch of built-in ones that you can use. You can also write your own. You can write your own tag helper, and it is ridiculously simple to do. Let's write one real quick. I'm going to write a Markdown tag helper. Okay, what I want to do is I want to be able to write some, have you ever heard of Markdown? Markdown's like this lightweight way of writing HTML. It's used on GitHub. I want to be able to write Markdown inside of my Razor view and have it render as HTML. Okay, so to do that, let's add a little folder. This folder is not needed. Just for convenience sake, I'm defining a tag helpers folder. You can put your tag helpers wherever you want. And let's add a new item. I want to add a tag helper. Yeah, okay, great. And let's call it, oh my goodness, time is going so fast. Markdown tag helper. Okay, so here's my Markdown tag helper. It's just a class that derives from tag helper, okay? And you can specify what tag you want it to bind to, or by convention, it will just use the name of the class. Like it'll use Markdown as the name of the tag, okay? And then I need something that can turn Markdown into HTML. Fortunately, there is a nice little community package available out there. I think it's called, the one I like to use is Common Mark. This guy, yeah. It supports .NET Core, which is great. I'm sure there's other ones out there. You use whatever you like. Okay, so restoring that looks good. Let me go back to my Markdown tag helper. So to do this, I get this tag helper output. This represents what I want to be rendered. So this guy's going to bind to a Markdown tag, and on the output, I want to first get its child content. That's an async call. So actually, I need to do task, process, async. I'm going to do the async version of this. And I'm going to await. So I need to put an async keyword on here. That looks good. OK, and var content equals that guy. OK. And now, what do I want to do? I want to do common mark dot, I think it's the common mark converter. And I want to convert some string. I need to get that string. How do I get the string? So the string is going to be content.get content to get the actual string representation of the child of the Markdown tag. That looks fine. And now I want to actually, I want to do output dot, I want to set, output dot content. So I want to set the content of the output to replace it with the actual rendered HTML. So I'm going to set the HTML content that comes out of that common mark call. Does that make sense? So I'm setting the HTML content to whatever was there before, which hopefully presumably was Markdown, but turned into HTML, okay? And then lastly, I want to make sure that there's no Markdown tag that shows up in the output. So I'm going to say output dot tag name, no, not tag mode, tag name equals null. I think that's it, okay? Now I'm going to build, make sure it builds. And then we do need to enable this tag helper. Like tag helpers in my project. So to do that, I go into my view imports file. And this is the directive you use to add tag helpers to your projects. So we already add all the built-in ones for you. I'm going to add tag helper, everything that I've got in here. What project is this? Web application 2. OK, cool. Great. So now let's go back to our about view. OK, and if I start typing Markdown, do you see how the tooling picked that up? You see that? I wish I don't know how to do the zoom thing, but trust me, it says Markdown right there, even though it's really small. And I can now type some Markdown here. So if you don't know Markdown, like asterisks mean, I think, like italics. And double asterisks mean bold. So if I say hello from Markdown and save that. Now if we go back to our About page and F5, hopefully we'll see some italic text and some bold text. Woo! Okay? So that's a custom tag hub. You can write these, write lots of them. It's really super fun. All right. I believe I'm just about out of time. There's lots of new stuff that's also coming. I mentioned URL rewriting support, response caching support. These are all part of our 1.1 wave, which we hope to ship by the end of this year. Web Listener is a new server that we're shipping, which is a server based off of HSP/sys. It's Windows only, but it enables some Windows only specific features. You'll be able to use middleware as MVC filters in the 1.1 wave. That will allow you to do things like if you want to say, I just want to compress just this one action. Like I want output compression for just this one action. You can do that with this model. Precompiled views is coming. View components as tag helpers. I didn't get to show that to you. It's pretty sweet. There's some good videos online you can look at for that one. And improved Azure integration. In the next wave after that, we're shipping support for SignalR. Web API security is coming. We're working on a page-based programming model for ASP NET Core that we call temporarily Razor Pages. That's not its final name, but that's what we're currently calling it. WebSockets is coming too. Unfortunately, we can't show you those things, but hopefully in some future talks we'll be able to demo those as well. There's a lot of great talks here at the conference about .NET Core and ASP.NET Core. I encourage you to go look at. I would strongly recommend going to see Richard Lander's .NET Core talk on Wednesday. He'll give you all the details on the underpinnings of everything I just showed you. I gave you a really light introduction to .NET Core, and we focused mostly on the web stack. He'll go really deep into what .NET Core is all about. EF Core is going to be discussed by Rowan on Thursday. And then if you want to do a deep dive of ASP.NET Core, maybe I'll save some of those 1.1 demos I didn't get to today. I'll put those on Friday. Then you now have an excuse for staying till Friday afternoon at Ignite. Thank you, everyone, for coming. Join us on GitHub. Read our docs. Try it out. And I'm happy to stick around to answer any questions that you might have.